Hello everybody, just Joe here. Today I want to talk about inverters for solar off-grid system. We already covered the solar panels, so now we're going to skip to the inverter. I will get to the charge controller and batteries on another video. So when buying an inverter, something I did not know when we bought one, there is such thing as a modified inverter and a pure sine wave inverter. A modified inverter is for power tools. You cannot use that in your off-grid system if you're using TV, I would think even a refrigerator, stuff like that. It's going to run at a more even hertz. So this one, for instance, runs at an even 60 hertz, which is what we need. You can change that if you are somewhere that you need 50 hertz. There is a dip switch to change that. But you do need a pure sine wave inverter to run your house. They cost more than modified inverters, but it's necessary. So our inverter is a 48 volt inverter. It is a Sun Gold Power. I went with that brand. It was for the money and for the quality, it was what we needed. That being said, it came obviously with the inverter, but it also came with a remote control panel that just simply plugs in here, so you can see all your information on this screen. You also have a screen on the actual inverter, but this gives more information. So we are running a 48 volt system. This is a 48 volt inverter. Some inverters you can switch from 24 to 48 or 12 to 24 back to 12. This particular one is strictly for 48 volts. So if you are running a 24 volt system with two 12 volt batteries hooked up, you can't switch that to a 48 volt system without getting another inverter. Like I said, some inverters you can change that factor. This particular one, you cannot. So, like I said, this is a Sun Gold Power Wave form inverter. It's a pure sine wave inverter. Like I said, you're gonna want to get a pure sine wave inverter. So on one end, this is where the batteries hook up. Like I said, we will discuss batteries and all that information in another video. You've got your positive from your batteries and your negative from your batteries. This is the remote control panel on the LCD screen I discussed. And these dip switches down here is where you can change. For instance, if you wanted to do a 50 hertz going into your house, you could switch this switch number 4 to a 50 hertz frequency. You got power saver mode, which we never use, the input range, and your battery low point. This particular one you can switch from 40 to 42. We leave it on 40 so it doesn't kick off as often. This particular one, if your batteries drop below 42 or 40, depending on where the switch is, it will kick off everything in the house. So if we turned on the hot water heater at midnight, it would drain the batteries and then kick off the system. Therefore, we do not charge the hot water heater until it's sunny outside. And if it's cloudy, we have to turn on the generator temporarily to charge that. So on this end is where it runs to the house. Down here you've got your AC output on top. AC output, this is what runs to the breaker box in the house. Once you get to the breaker box, it's pretty much no different than an on-grid system. This down here is the AC input, which is, like I said, the generator. So this is a 240 volt extension cord with one end cut off. It's plugged into the generator, and then the other end plugs in here. So once this hits 42, if I had the generator running and we got down to 42, that would kick on. So it literally just hooks up, this right here hooks up to that end. The other end goes in through this PVC pipe into the house. I also have another wire that's hooked up to the output that runs across to this shed, just so I have electricity out there. So as you can see, there's two white wires here. That little white one goes to my closet shed, and the big one goes to the house. Back to the inverter, once again, getting off topic. This inverter has two internal fans. If it gets really hot, obviously it kicks on. If the hot water heater is on, it kicks on. Just one of the two kicks on. On top of the inverter, you have all these lights. Oh, let's see. So if the inverter drained the batteries down to 42 and the generator kicks on, this light is going to come on, letting us know that we're charging from the generator, not the sun. This charge control, this current charge current control, hello. This allows you to turn up the charge or down the charge from the generator. We pretty much leave it in the same position at about 35-40%, because at that we can turn on the coffee maker, turn on the, which I know that sounds ridiculous to turn on the coffee maker, but if it's turned up too high, it will kick the generator off. So we just leave it there. Your battery type selector here, you're gonna pick which batteries you use and turn it to that control depending on this diagram. We use AGM or absorbent glass mat batteries, so it stays on 2 all the time. Like I said, we never use the power saver mode, and we just leave this in unit off because the remote control panel overrides the system. So if this is on, this is on. So we just turn one switch on. The display is going to show you your battery DC voltage, which right now it's a sunny day, and where our charge controller is at absorb. So we're all the way up to 58.4. That's creepy. The output load is at 1%. Just for reference, for people who don't have an off-grid system, that 1% right now is the fridge is probably running, and that's probably the only thing that is running. That being said, when we first did this, I was amazed at how little energy the fridge uses. It is a 22.8 or 23 cubic foot fridge, I believe. So it's pretty big, plenty big for any family. It is an Energy Star rated fridge. Obviously, when you're doing off-grid, you're going to want to get as many Energy Star appliances as you can. With the hot water heater, for instance, it's a 19-gallon hot water heater, and most people are going to be like, well, why is it not 20? We went with a 19-gallon hot water heater because it just has one heating element as opposed to 2. So it's going to take longer to heat, but it uses less electricity to turn on. So if we turned on the hot water heater now and it did kick on, this output load would kick up to 55%. That's pretty much our biggest energy user in the house, is the hot water heater. Obviously you could go with gas and it wouldn't even affect this, but it is nice to not have to deal with gas. We turn it on an average day. It may take 45 minutes or an hour to heat up. but we have it set to 140 degrees, and that works plenty well for 2 people. And there's still hot water heater, still hot water in the hot water heater after that, so it doesn't take the full term to heat up the next day. If it's really cold, sometimes it takes an hour and 15 minutes if it's drained. But like I said, if it's sunny outside, we just turn it on until it kicks off. Surprisingly, you wouldn't think it would matter, but everything charges better with sun electricity than with a generator. From my understanding, it's because this 60 hertz on your output frequency, if we turn on the generator, if the sun was not out and we had to turn on the generator, this may change to 61 or 59, and I'm assuming that's why it takes a little bit longer to do its thing, because it's not at an even 60 hertz. What else was I going to put in here? Other than that, I do want to discuss an ohm reader. Oh, this right here is an ohm reader, or a resistor as they call it. So you're going to need a resistor to pre-charge and discharge your transistors in your inverter. The smallest spark can break a lot of stuff, we learned. So if you were hooking this inverter up for the first time, that's really the only time I've used this. Just like anything else, if you're jumping off a car, if you're hooking an inverter up, if you're hooking a charge controller up, everything goes the same way. If you're hooking it up, you do the addition first because you're adding it. So if you're adding the batteries to the system, just like if you're jumping off a car, you're going to do your positive first and then your negative. If you're subtracting them from the system, you're going to take this off first and this. So it's confusing unless you just remember, if you're adding something to the system, if you're jumping off a car and you're adding the jumper cables, you're going to do the positive first. Then when you go to take it off, you're taking it off, so you do the subtraction first. So a lot of people can't remember that, but if you just remember, if you're adding it to, you do the positive first. If you're doing the negative, if you're taking it off, if we were taking this apart, we would take this off first. So if we were hooking this up for the first time, we would be adding the batteries to the system. So we would hook the positive up. Then we would take this little thing. We would wrap one end around the cable and then lightly touch the other end to this metal bar here. That is going to pre-charge the transistors in the inverter. Therefore, as soon as you take 3 to 5 seconds, then as soon as you take this off and you put that on, it's not going to cause a spark. So you're basically making sure you don't break anything is the main goal. You don't want to break anything or fry anything. There's a lot of terminals in this thing, and it doesn't take much. So you do want to get, and I will leave a link in the description on where I got this. It didn't even cost that much. It will save your peace of mind, and it could save a lot of money to have one of these. And I just leave it here in case I need it. If I need to take something off or put something on. Like I said, you only need it to pre-charge your transistors or to just discharge your transistors if you were, say, going to store this for a while and you wanted to make sure there was no energy left in it. That's really the only 2 times you would use that. So, other than that, it does have a grounding terminal. So you're going to want to ground that to a grounding rod. So this runs out to a grounding rod in the carport. I'm assuming you could, right there, I'm assuming you could use the same one on your house if you wanted to. We have another one over there. But it was so far of a distance, I didn't want to cross the breezeway, so I just did another grounding rod. We did have a bad experience last year. For those of you who are building off-grid and happen to be close to a electricity line, like we are, because we could very easily hook up to the electricity because it's right there, but we chose to not. That being said, we had a really bad lightning storm last year. My cousin was here. What's up, Becca? She left. She went to her mom's. As soon as she left, we all heard a loud crash of lightning. And I was in the kitchen and I saw it run down from that end. I don't know where it hit, but it ran down this electricity line. All these electricity poles have their own grounding system in there. Somehow, the lightning came through the line, down the pole, and up through that grounding rod. Come to find out, it's called ground saturation. So if you're building off-grid, just remember that if you're close to an electricity line, it depends on, it says it can do it for up to a mile. We're obviously way closer than a mile, and it is kind of a freak accident kind of thing, but it still happened. When that happened, it fried our inverter. So if I wouldn't have had the inverter grounded, I guess it probably would have fried something else, the charge controller, through the solar panels, or came up through that grounding rod and, you know, could have started a fire in the house. It's electricity, so who knows? But that was a freak accident, but it did happen, and it was not a good thing. So we had to get another inverter. So yeah, ground saturation, not a good thing. But you do want to have your inverter grounded, for obvious reasons. Talked about the transistors. I guess that's about it, guys. I feel like I'm just rambling. If you have any questions, leave them in the comments and I will be happy to answer. I will be making another video as soon as I try to do it tomorrow. I'm trying to do one a day about the batteries, how that system works, and the charge controller, but I just wanted to do each component separately to make it a little more self-explanatory, a little easier to understand. The main takeaways from this is pure sine wave inverter, number one, not a modified inverter. Ohm reader, or I think some people call it a transistor. So you will need a transistor to pre-charge and discharge your, a resistor to pre-charge and discharge your transistors in your inverter. And like I said, you probably could get away with not using it and it cause a little spark, but better safe than sorry. I mean, it was like less than $20 for that, and this is like $1,000 inverter or $1,200 inverter, so it's best to just have that on site. So I guess that's about it, guys. Like I said, just questions, comments, leave in the comments, and if needed, I'll make another video about the same thing. But that's about it, guys. Y'all have a good day. Thanks for watching. Bye.